Welcome back, devs, to this explainer. I'm so glad you could join me. Let's just pretend we're sitting right next to each other, grabbing a coffee and reviewing a pull request together. As a senior engineer, one of my absolute favorite things to do is break down exactly how we build robust, production-ready applications. So today, we're going to walk through building a resilient Spring Boot REST client step by step. All right, let's dive right in. Here's our roadmap for today. We'll start with the REST client being set up, then break down the code, look at timeouts and request factories, base URLs, and headers, cover why one instance really matters, and finally, wrap up with a summary and next steps. Okay, part 1, the REST client being set up. So here is the big picture. This is our complete REST client config class. When you're building out integrations, you really want to create your client exactly once as a Spring Bean and configure everything it needs in one centralized place. Just look at this snippet. Inside our @configuration class, we're setting up the base URL, we're defining both our connect and read timeouts, and establishing the default headers that should go out with every single call. Having all this in one tidy place, it's honestly a hallmark of clean architecture. Moving on to part 2, breaking down the code. Starting right on line 1, we use the @bean annotation on our JSON placeholder REST client method. In Spring, you probably know this, registers the client as a singleton in the application context. This means Spring creates exactly one instance of this REST client and hands that exact same instance out everywhere you inject it in your app. We're going to talk a bit more about why that specific behavior is an absolute game changer for performance in just a few minutes. Now, looking at line 2, check out the method parameters. JSON placeholder props. Here, Spring directly injects our bound configuration record. I mean, we've all had to redeploy an entire application just to change a single hard-coded URL, right? Total nightmare. By injecting these properties, every single value, the URL, the timeouts, the client name, comes directly from your application.properties or YAML file. Absolutely nothing is hard-coded. It makes this code completely decoupled and perfectly ready for different environments. All right, part 3, timeouts and request factories. So let's unpack how we actually separate our connect and read timeouts. On line 3, we declare our HTTP client and we set the connect timeout directly on the JDK HTTP client. Why do we do it there? Well, because that underlying layer is the one that actually owns the process of establishing the network connection to the server. Then on line 4, we wrap that client with our JdkClientHttpRequestFactory, and we call .setReadTimeout on that factory. We set the read timeout on the request factory instead because once the connection is established, reading the actual data response is the factory-specific responsibility. I just love this. It's a beautiful separation of concerns. Next up, part 4, base URLs and headers. The crucial part here is how we tie it all together by returning RESTClient.builder. We chain our methods super methodically. Step 1, we call .base URL. This establishes the prefix so every later call you make only needs a relative path, like /posts. Step 2, we attach that carefully configured request factory we just made. And step 3, we append our default headers. We ensure we always ask for JSON with the accept header, and we pass along our client identifier using the xClient name header. These headers will literally accompany every single request this client makes, which saves you from repeating yourself over and over in your service layer. Finally, we just call .build to lock the whole shebang in. Okay, part 5, why one instance matters. Remember that @bean annotation from line 1? Creating exactly one instance per upstream service is highly intentional. Under the hood, every single REST client owns its own connection pool, its own DNS cache, and its own observability context. That is a lot of expensive overhead. Early in my career, I actually saw applications totally crash under heavy load just because the developer used the new keyword to spin up a fresh client inside their service method for every single API call. They were throwing away all that valuable caching and completely exhausting system resources. Reusing the singleton bean ensures your application stays fast, efficient, and super light on memory. And finally, part 6, summary and next steps. This whole setup brilliantly illustrates what good Spring Boot configuration actually looks like. So to summarize what we accomplished, we created one REST client bean globally. We successfully decoupled our configuration by injecting properties, which completely eliminates hard coding. We properly split our responsibilities by applying the connect timeout to the HTTP client and the read timeout to the request factory. And probably most importantly, we leveraged a singleton bean to safely preserve our valuable connection pools and caches. I really hope you found this little pull request review helpful. Please be sure to check out the detailed article link in the description for more context and code snippets. You definitely won't want to miss our deep dive into the nuances of network behavior, so be sure to join me in the next part, Connect versus Read Timeout, Why Both Matter. Happy coding, and I'll see you there.